All right, thanks everyone for coming. Today we've got Jakub, and he's going to be presenting his work on exploring pre-interaction feedback for human-robot interaction. Take it away.
Hi, I'm Jakub Zlotowski, and I will talk today about pre-interaction feedback in human-robot interaction. I had been working on this topic at the University of Salzburg, where I used to work as a research fellow before coming to the HIT lab, and I have done the work together with my colleagues Ewald, Astrid, and Manfred. So I put this little logo of the University of Salzburg at the beginning of the presentation. So I understood that the idea is also that I introduce myself a bit, and I prepared this short information about my previous education. So I have started my studies in 2004. I have studied social psychology of IT and communication at the Warsaw School of Social Sciences and Humanities back in Poland, which is my home country. But after 2 years, I went for an exchange program to the University of Tampere in Finland, and finally I transferred my studies over there. I have graduated with MSc in Interactive Technology from the University of Tampere in 2010. And upon my graduation, I moved to the University of Salzburg, where I work as a research fellow until January this year. And the work which I'm going to present today has been done during that period. So the outline for today's presentation is, first I will talk a bit about Euro project. This is the project on which I had been working. I will tell you a bit about pre-beginning sequence, and then I will present 2 studies, one of which became a pre-study on pre-interaction feedback in human-robot interaction, and the second one is a follow-up study. And I will end with conclusions of these 2 studies. So the Euro project is a European Union project, and there are 4 university partners from different European Union countries and 1 industrial company involved. And the full name of the project is Interactive Urban Robot. So the goal of the project is to develop and implement methods and technologies enabling robots to navigate, interact in densely populated, unknown human-centered environments and retrieve information from human partners in order to achieve a given navigation or interaction goal. So in simpler words, the idea is to turn around the basic concept that the robots will be the ones who always provide help to humans. The project tries to find out what would happen if a robot requires help from a human. And in particular, the scenario that the project was interested in is a scenario where the robot must navigate from one place in a city to another by asking people for directions. So it doesn't have access to neither internet nor GPS data, and it must understand the basics, gesture. It must have a gesture recognition, and as well as it must understand basic verbal human input in order to achieve its goal. So we wanted to find out how the people will behave once the robot asks for help, and also how to increase the robot's chances of receiving that help. Here is the picture of the Euro head. This is a new head. It has been put on the robot after I already left. So during the studies which I'm going to present, it has not been used, but it's capable of displaying 6 basic emotions. And the old head was capable of doing the same, but it looks slightly differently. You will see it on the pictures a bit later. A bit on the theoretical side, so what's the pre-beginning sequence? According to Sheglow, it's a sequence initiated by turn types built to be specifically preliminary to some other turn type, whose subsequent occurrence is projected to occur contingent on the response which the interlocutor gives to pre-sequence's first Pearpad. So that's maybe a bit overcomplicated definition, but basically what it is what happens actually before the actual interaction starts. So it's the phase when two strangers establish an interaction space and become co-participants of interaction. And what happens before they start communicating can affect the interaction which will follow. So the aspects that we were interested in during in these two studies that I'm presenting right now were distance, approach trajectories, and speed. So basically, it's at what distance the robot should interact with a human. The trajectories refers to the approach trajectories, so from which side the robot should approach a human, and what would be the appropriate speed for a robot approaching a human in a public space. The previous studies on distance, interaction distance in psychology showed that people have preferences at what should be the distance between two strangers or two people who know each other quite well, and that distance differs. So depending on the intimacy relationship between the co-participants, the distance is different, and other factors such as social standing can affect this distance too. The studies on human-robot interactions showed that the distance for human-robot interaction is a bit smaller than for the interaction between humans, which means that people prefer to interact with strangers in their social space, which is more than 1.2 meters. However, with the robots, they feel fine in the personal space, which is between 45 centimeters to 1.2 meter. And even more, some of the people indicated that the intimate space, which is less than 45 centimeters, would be fine for interaction with the robots. But as you see from the picture, Euro robot is quite tall or high, depends how you perceive it. It's pretty much human size. It's over 1.8 meters high. So we wanted to see whether these distance preferences will be the same in case of Euro robot. As for the trajectories, in the past, human beings were perceived in the studies on robotics rather as an obstacle, so the goal was actually to avoid them. But in the recent years, there is increased focus on finding out how to approach humans in a way that will be socially acceptable. And the original studies in the field of human-robot interaction on investigating the approach trajectories involved a fetch and carry task, where a robot was supposed to bring a remote control to a seated participant. So the studies show that people prefer to be approached either from the front left or the front right side rather than frontally. However, that was very context dependent. So if the person was standing in the middle of the room, for example, there was no difference between the approach trajectories. So it was acceptable that the person approached frontally. But at the same time, if the person was standing next to the wall, people preferred not to be approached frontally. So what we wanted to find out, how these findings also relate to the public space, because it was done mainly in the lab settings, and the Euro scenario involves public space. So in order to answer the questions, we have first conducted the first study. We have pre-recorded 6 short videos. They were approximately 15 seconds long. And in these videos, the robot approached a person from front left, front right, or frontally. And the actor was either standing or walking, so probably the two most common situations in public space, such as streets. Therefore, there were 6 different experimental conditions. The actor was our colleague who followed a script how he should behave. And the videos were recorded in a corridor of the University of Munich, Technological University of Munich. And the robot approached the actor and asked for directions to the assembly hall. After the person showed the direction where the robot should go and gave the answer to the robot thanked the interaction participant and follow the pointed direction. At this point, the video stopped, and most of the video was from the third-person view. However, during the dialogue, we have used the first-person view. So there was a camera mounted on the head of the actor, so you could see what he sees. And the robot approached with a speed of 0.6 meters per second, and the distance of 2 meters is slowed down to 0.4 meters. We didn't manipulate it in the study, and actually that was the default speed of the robot, so due to technical issues, we just had to stick with it and wanted to find out if that would be appropriate or something should be done with it. And finally, the interaction distance was established in human personal space. So the robot always stopped within 0.45 to 1.2 meters in front of the interaction partner in all of the conditions. Unfortunately, I do not have the videos from the study which we used, as I don't have the access to the University of Salzburg servers anymore. But our colleagues from Technology University of Munich prepared some other video, and it pretty much shows how the scenario looked like. So it's a short video where you can see how the interaction more or less potentially look like. So about the procedure of the first study, we have used a video-based method. So it's basically, we have conducted the study in the lab settings using the pre-recorded videos, as I have mentioned. And there were 30 participants recruited. We have used the University of Salzburg blackboards to recruit them. So majority of them were university students. 3 videos were presented to each of the participants in the static condition, which is when the actor was standing, and dynamic condition when the actor was walking. So basically, it was done the way that first they saw 3 videos either in a static or a dynamic condition. And after each video, they were asked on a 9-point Likert scale about their preferences for the speed, distance, and trajectories. And after each block, so either after all 3 videos in a static condition or 3 videos in a dynamic condition, we have used AMP procedure, which is affect misattribution procedure, that measures implicit attitudes towards an object. So we were interested in perception of abstract patterns as beautiful or ugly based on an object displayed before. We have used Chinese characters as they did not have any meaning for our participants. I guess if you have Chinese native speakers, you probably should look for different objects because the object itself might have a meaning, but for our participants, it was probably meaningless. And the idea is how it works is that before showing this abstract object, you display briefly, in our case, the picture of the robot or the actor. And based on what's the attitude towards the robot the person will perceive differently Chinese character. So the concept is that it should perceive it as more pleasant if the robot was liked. In opposite situation, if the robot was disliked, the Chinese characters should be perceived as less pleasant. And you can find more about the procedure in the publication from my colleague Evald, who was doing actually this part of the study, if you are interested in it. Going to the results, so what we found is that in static condition, there was a non-significant trend for preferring the front right over frontal approach trajectories, which means we have conducted Friedman's analysis of variance, but it was significant. However, the post-hocs were not significant. Therefore, we didn't find any differences between the groups, and we were only able to show this trend. In the dynamic conditions, there were no significant differences. As for the speed and the stopping distance, they were found comfortable for the participants, and there was no difference depending on whether from which side the robot approached the person. The AMP part of the study, in that part we have used only the data from participants who neither had prior experience with robots or extreme conscious attitudes towards them. It's basically because the video was relatively short and it's impossible to affect their attitude towards the robot just with such a short video. And the robot was perceived more negatively when it approached a walking compared to a standing person. Therefore, we concluded that the robot, if possible, should avoid approaching walking people in a public space and if it wants to request help. However, as in the previous slides you saw from the results, we were able only to show the trends, and since they were not significant, we were not able to really conclude much. So we decided to repeat the study with bigger sample. Therefore, we have conducted a follow-up study, which was an online survey. We have used the same videos, and we used Lime survey for that. We have recruited 182 participants. They were recruited using the scientific mailing list, as well as we have sent an email to all the staff and all the students at the University of Salzburg. So we have used 182 participants answered all the questions, and we have used only their data for the analysis. And participants were either assigned to the dynamic or static conditions. So that's the difference compared to the previous study, where each participant saw all the 6 videos. Now they saw only 3 videos. They were either in the dynamic or static condition. And further change was that we decreased the scale. Now it's only 5-point Likert scale, and that's based on the feedback from the participants from the first study. So participants basically after each video had to go through the same procedure, so answer these 3 questions on the 5-point Likert scale. And going directly to the results of this study, in the dynamic condition, we found out that participants preferred front right and front left trajectories over the frontal approach. So the conducted analysis of variance was significant, and we used the least significant difference post-hocs. And these 2 groups differed from the frontal approach. However, in the static condition, we did not find any preferences regarding robots' approach trajectories. Therefore, it did not matter whether the robot approached frontally or from one of the sides. As for the interaction distance, in the dynamic condition, stopping in human personal space was perceived as too close when the robot approached frontally. That's important here to mention that actually the scale was from 1 to 5, but 1 was too close, 3 was about right, and then 5 was too far. So so though the robot stopped at the same distance in each of the conditions, people were not comfortable when it stopped in their personal space while they were walking towards it. What we think and we believe that's responsible for this is that basically if the person walks towards the robot and the robot approaches you and you don't know the robot, there is a potential that the robot actually doesn't see you and it might bump at you. So it simply might increase the fear of the participants that there might be an accident with the robot. However, if the person is standing, even if the robot is approaching you, you have much bigger possibility to step aside or do something to avoid the collision. And to conclude the results of these two studies, we found out that the approach trajectories can be an important feedback modality for robots seeking help. And the robots definitely should approach people in a socially acceptable way, because that potentially leads to higher effectiveness of the interaction, which means if the robot is able to begin the interaction in a socially acceptable way, there is a higher chance that the human will want to provide help to the robot and therefore increase its efficiency. And approaching a walking person can lead to more negative implicit attitude. Therefore, the robot should avoid approaching a walking person in public space. And if that's not possible, then definitely the robot should not approach that person frontally. However, if the person is just standing, the approach trajectories don't matter that much. So as long as the robot does not approach a person from behind, that should be fine. And final conclusion is that use speed and distance were appropriate for the Euro robot, at least. It's hard to generalize the results for other robots. Apart from the frontal approach, where in the dynamic condition, so when a person is walking, the robot probably should stop in a social space, so further than 1.2 meters away from the robot. If you are more interested to find out more about Euro project, you can find more information on the following website, and you can also find the list of publications. It also includes some publications that use the results that I have presented today. Thank you very much for your attention, and if you have any questions. Yeah.
What is your take on how good video can be used to simulate human-robot interaction? As far as I understood now, people watched videos and they made judgments, and it might be quite something different than when you are actually approached by a robot yourself. Very different. What is your take on can video replace human-robot?
Yes, actually that was the reason why our full paper was rejected for HRI. But the thing is that there have been previous studies conducted where they have compared exactly the same thing. So they were interested, though it was for the seated person, they were interested if there is a difference between the video-based method. So that's what we have used. For the preferences and for the perception of the approach trajectories and interaction distance. And so they had the participants who saw the videos, similar case to ours, or actually interacted with the real robot, and they found no differences between these conditions. Sorry?
Was it down part in
Yeah. So they had like at least 2 experiments, as far as I know. So that's why we went for this method, since we have pretty much done exactly the same what they were doing. Just the only thing is, the main question is whether you can really feel walking. So because what they considered, it was just a sitting situation, where the participant is sitting, but can you get an impression of walking from a video. That's another question. Yeah.
On the same lines, third person versus first person view. It seems like this was in third person view. Do you think the results would have been different? Or how would they be affected if it was
Only first
a
person.
robot approach? First person view, robot approach to
Hard for me to say, but the thing is why we use exactly this approach is again going back to the other studies. They yeah, but they used exactly did it the same way. So they used the third person view first, and then they switched to the first person view. And so since we wanted to use the same methodology, and we hope to avoid too much criticism just for that, we decided to just follow exactly their setup. But yeah, that's interesting question. If that would have affected perception. Also, the thing is that all the videos that we have recorded were recorded from one angle. So it's possible that when the robot approached from the, so what I mean is when the robot approached from the front right side, it was actually closer to the camera than when it approached from the front left, because that was exactly opposite end.
I have a general question or maybe criticism about what you're trying to answer and how you're trying to answer. What question you're trying to answer and how you're trying to answer the question. So if you're asking me how a robot should approach me, then I think I should see it from that point of view. If you're asking how should a robot approach people, then it seems like a third person view might be better. So what question were you trying to answer? Which one of those are you trying to answer? Project. I'm not criticizing you,
Yeah,
just
no.
in general. I think it's an interesting question. Both interesting questions, I guess. But if it's about how robots should approach people, it should be about how I feel about it from my point of view, how a robot should approach people. And related to that is, you talked about how people approach people.
Mm-hmm.
And how do your results correlate with the same video of a person approaching a person as opposed to a robot approaching a person? It'd be nice to know. I mean, you quoted some results about interpersonal.
Yeah, but they didn't use the videos. It was just
Yeah.
no interaction. Yeah, that's point.
Well, I was wondering because sometimes if someone has to stop me, or for example, imagine the robot, maybe my own state, for example, if I hurry up to do something, or I'm like walking without any objective, maybe I would answer differently depending how the robot approaches me. And this is the state of the user that is being stopped. Do you think that can influence, or you can make?
That's a good point. I mean, in a way, if I would go over a space in Salzburg, and say I'm in a certain context, like I'm running to the bus, or just had a good time with my friends, or I'm pissed at my boss, or I don't know, there's a certain context in which I am. And if I then in a public space, and then a robot approaches me and something else, and I'm sitting comfortably in this chair, and I'm watching a video on a computer screen, and I'm not in it.
Yeah, I think you are right, but the problem is how the robot is. I mean, it's gonna take quite a while, I guess, before the robots actually will be capable of perceiving your state. And I mean, even then, it's
Not the intention that they should do that. It's just that people will respond differently in terms of, is it appropriate for the robot to approach me now?
Okay.
Because people in public space go walking around, doing around, they are in a certain context.
Yeah.
If you take the same people, you put them in the laboratory, say, now your task is to interact with the robot.
Yeah, it's completely different. Yeah.
But was it my gut's feeling is that the main reason why you guys use video is that it's easier?
Yeah. Well, basically, the robot was not able at that point of time to really do any studies outdoor, so or even indoor.
Remote control for that? I mean, like,
Oh yeah, sorry, I didn't mention that for the. But yeah, the robot was remote controlled. It was not autonomous, so.
okay. But it doesn't make a difference because, I mean, if you have a video of how it's remote controlled, or
It's an actor anyway. I mean,
yeah, it's an
the
actor
person
anyway.
in the video was an actor anyway.
Oh, was an actor?
Yeah, it was our colleague. Yeah.
So it was a robot.
I think one of the guys in HRI says one of the problems in the HRI conference is it shouldn't actually call it human robot interaction, it should be called human puppet interaction.
Yeah.
that's why it ends up being very often.
Yeah, but these were the two main reasons for going for a video. That first of all, it was easier, and to also to ensure the same conditions, between the participants. And second of all, we were really not able at that point of time to take the robots
The
anywhere.
thing across my mind is like when you actually showed the graph for differences, it was like 0.2 difference or so, like 3.5 to 3.2 or something like this. 182 participants. That would look to me like it's a small effect, to say the least. Then it could also be something like, well, if you just throw enough people, enough participants at it, law of large numbers, anything turns significant. So it's a very small difference. Is that really relevant?
It is only out of 5. It is only out of 5. So half an integer is
Statistically, it might be, but
quite low.
clinically.
Statistically, half an integer in this situation is a lot.
Statistically, clinically, whether I think it's 3.25.
Do you plan on doing more studies of like using facial expressions through the robot? People's
No, we didn't play with the emotions in this study, but the robots used its mouth was animated while talking. So that's why we switched also to the first-person view, so that you actually can see the robot talking. Yeah.
I want the robot to ask questions. Was it a real person actually asking?
Sorry?
So when the robot stops somebody,
Yeah.
direction, was it a real person in the background?
Oh no, we have pre-recorded it. So the robot actually, in a way, had output. It was just text-to-speech output.
Okay,
So
not like a live sort of,
no.
but really a person behind the scenes.
No, it was a live. I mean, we have pre-recorded the what the robot is gonna say, and then once the teleoperator stopped the robot, he just initiated the speech. Yeah.
Yeah, I wondered if it was a microphone and another actor behind the scenes and you'd say, direction to the research.
No, it was pretty much robotic voice.
Are you planning on taking this kind of study out?
Well, I'm not gonna work on it anymore because this was our work. My work in Salzburg, and I'm working on different topic here. But yeah, the concept was to repeat the study in field. Well, that was the goal actually, to confirm the results in field, because as well, you and we agree for the same that might be really necessary for this study, in order to generalize the results and to find out.
If there's no other questions, just give Jakub another hand.